well, you could argue that the SSL server is not really operational. It's there for some other reason. And speaking about the expired certificates, we have a distribution of, first we looked at how long would the certificates be valid for. By far it's 1 year. Most certificates are valid for a year. And then we have 2, 3, 4, and 5 years. Surprisingly, nobody likes to go for 4 years. They skip that and go to 5. But then we're looking at the expired certificates. You can see that the largest number of expired certificates have expired about 6 months ago. So you could say that there's a large group of these who are either forgotten or not really very important to site owners. And then after that, you have a long tail of what's probably abandoned SSL certificates and probably abandoned sites. Going back to the other reason why we couldn't trust so many certificates, and by the way, I should mention that in our test we used the Firefox 3.6.0 trust base, and so the survey results would roughly match the results that you will get with Firefox. So we looked at all the unknown issuers. The issue with certificates that is if you don't trust the issuing certificate authority, then you cannot trust the certificate itself. And we looked at most of these, all the major ones, to make sure that we are not excluding anyone without a good reason. We have found 4 that you could argue should be valid. We have the first server encryption certificates, quite a few website with those websites, and apparently they're a subsidiary of Yahoo in Japan. So I would venture a guess that these certificates are valid for the people in Japan, but for some, they're not included in Mozilla. CSCert is there, and although they wanted to be included in Mozilla, they couldn't get the audits to go through, and eventually they didn't work out. And there are two further certificate authorities that are somewhat controversial, but they're primarily not in Mozilla because they didn't do the necessary legwork, basically, to be included. So, talking about the trust, the way trust works with SSL certificates is you have basically trust anchors, which are the root certificate authorities that browsers trust. They will sometimes issue certificates directly. Most often than not, they will delegate that responsibility to other intermediate certificates, either for technical reasons, in which case they would control the intermediate certificates as well, or because they want to delegate the responsibility of issuing certificates to other organizations. We saw 429 different certificate issuers, but we could track those to only about 78 root trust anchors, which is about only 50%, because Mozilla, the Firefox 3.6.0 would include about 155 of these trust anchors. And you can see that the length from the root certificate authority is, I'm sorry about that, so I'm just going to kill it. So you can see that the length between the root certificate and the actual web server certificate is usually, the chain length is 2. And by far, then 3, 4, 5, and 6. Most sites are either 2, which means the certificate authorities will issue certificates directly, or 3, where there's an intermediate certificate. Certificate chain correctness, it's when you have a certificate chain, you have to make sure that the chain is correct, and that if it's not, that the certificate cannot be trusted. The good news here is that most sites have them configured correctly, and about a small number, about 6%, don't, mostly because the chain is incomplete. They haven't. You actually have to include all these intermediate certificates in your configuration. So when a user opens a connection to the browser, it has to get all the pieces of the chain. And some sites really forget to do that, and that's about 32,000 sites. And also, a problem can sometimes be if these certificates are not in the correct order. So what so far this points to give you an early conclusion, is that basically most people find SSL difficult to configure. And there are always these, and as you will see also later on, there are all these small problems. And although maybe not any single problem is big in itself, there are many of these small problems that affect, in aggregate, actually affect a great number of users and essentially diminish the effectiveness of SSL. Here we look, for example, one surprising conclusion, I will go back to the previous slide. One surprising conclusion is that as much as 43% of all sites actually send more certificates than they should. And this is a potential performance issue. In the TCP protocol, the first several packet exchanges are critical because there's a ramp-up period and every TCP connection starts slow and then increases in performance. So the more data you send in the early beginnings actually slows down your SSL connection. You really want that SSL handshake to be completed in as few packets as possible. When you send too many SSL certificates because you will have them in the chain, or if the certificates are long, if you increase the size of the SSL handshake, which will ultimately create a problem for your performance. And we have found quite a lot of really misconfigured servers, whereas most will send I don't know, 1, 2, or 3 certificates. There are many sites that will actually send 4, 5, 6, and in one really extreme case, 116 different certificates, which is a huge amount, which is in excess of 100 kilobytes for every SSL handshake. And that's before you even see the first byte in an HTML page. And so in the far right column, you actually see, in the second 2 columns, you can see how many sites send, for example, 1 certificate, and how many the sites should be sending that 1 certificate. Anyway, the bottom line is that 45% of sites send more, and that's really sloppy configuration. I have traced the root cause to the certificate authorities themselves, who in the instructions on how to configure the SSL sites will include the final CA certificate, although that CA certificate is not really needed for the handshake. The other, speaking of performance, the other very important performance factor is session resumption. Basically, SSL works in SSL you have the handshake, which is time-consuming and requires CPU resources, and there's a so-called resumption mechanism that allows all subsequent connections to avoid the expensive SSL handshake. The good news is that 90% of all sites actually support session resumption, and that a very small number of sites either do not support it or support it or claim to support it, but they don't actually do. And which brings me to an interesting part of the SSL survey, which is where we look at the trust anchors. And we look at these organizations that actually sign certificates on the internet. And these are basically the key to the trust on the internet. And it's what can make or break SSL. And what we have discovered is out of 429 issuers, you can see the top list, there's about 18 trust anchors here in the table, and they issue about 97% of all certificates. You can see who by the way, this is not a market, it's not overview of the market, this is look at the certificates. Some certificate authorities will have multiple trust anchors. So if you're looking for market share table, this is not it. So you can see who leads. You can see that in our survey we've seen the most GoDaddy certificates, followed by Equifax, and then followed by others. Now, if we look at those, I mentioned that we saw 429 issuers, but only 78 trust anchors. That means that for every trust anchor, there's actually 5.5 intermediate certificate or subordinate certificate authorities. But not all of these certificate authorities issue as many sub-CAs as others. And so we looked as to how many there are for each trust anchor. And we can see that by far, Deutsche Telekom, actually we have seen 169 sub-CAs issued by the Deutsche Telekom. And then we have GTE Cybertrust with 48, and user first hardware with 29. And then the numbers just fall down to the bottom. So you can see the top 3 here. These are those CAs who have it in their business model to sell CAs and to other organizations that we know about. And these are because this study is about the public internet. So what happens in private, we don't really know. Perhaps there are many organizations that use these certificate authorities internally. And the question is, how many trust anchors do we need? And the answer is, in the nutshell, it's about 10. The catch is that every user will probably need a different 10 trust anchors. If you use 11, say 10 or 11 trust anchors, you will cover 90% of all the certificates that we had. If you increase the number to 23, it's 99.1%, and if you increase it to 42, it's 99.9%. And from here on, I have a couple of slides that will interest those who actually are interested in the protocol itself. We looked at the various other aspects of the configuration and the way certificates were created. You can see that virtually all certificates today are RSA signed, and there's only 3 out of the 600,000 certificates that we trusted that are actually DSA. The signature, the SHA-1 hashing function is used as the signature in virtually all cases, which is a bit troubling considering the SHA-1 is considered to be a bit shaky as far as security is concerned, and the general advice is to progress to the SHA-2 family, but there's virtually no support for the SHA-2 family at the moment. The size of most certificates is generally adequate. Almost 400 certificates have the key, which is about 1024 bits old. Most recommendation will be that we should really abandon 1024 bits by the end of 2010 and further use only 2048 bits or higher. And many, if not many certificate authorities will have stopped issuing the 1024-bit certificates. So the key size is generally adequate, and there's a very small number of sites that use higher strength. Support for multiple domain numbers. This is a topic that really generally interests me, only because for a certificate to be valid, the trust of the SSL certificates, that depends on us not confusing end users. And when you have a site, a legitimate site, it doesn't have a proper certificate, and it doesn't work for all the domain names that it was supposed to, we actually confuse our users and we break their trust. And what we have today is that whenever end user sees a warning, an SSL warning, in 99% of the cases or even more, there will be no consequence to them for accepting to go through and go to the original website. Which means that basically when that user has a need for SSL to protect him or her, the user will actually click through the warning, and then SSL will not work in protecting the users from man-in-the-middle attacks. So my pet peeve when it comes to SSL is that all sites should have certificates that should be valid for the main domain name, but also for the domain name with the www prefix. And unfortunately, I can tell you that it's only 35%, roughly 1/3 of all sites that do this, and by far, far too many sites actually do not support it. The rest of the slide will tell you as to how many wildcard certificates there are, and we also point to some really innovative uses of the certificates that would include some sites that will be valid that have 252 alternative domain names. So these are certificates that are issued for 252 domain names. And some of these sites will actually have all these domain names as wildcards. This is really the issue with the second big problem of SSL, which is that virtual SSL hosting is not possible. Today, if you want to have an SSL server, you really have to have a unique IP address. And so the fact that all these sites are actually putting this many hundreds of domain names into a single certificate is a way of actually making some virtual